All right, you guys. So we're going to look at what is called the remainder and factor theorems in our next section. All right. So follow along with me, and you'll see that we're talking about synthetic division. So you already learned how to do that. We're going to use the technique of synthetic division to evaluate a polynomial using the remainder theorem. It's going to sound more confusing than it actually is, so just bear with me. Then we're going to use the factor theorem to solve a polynomial equation. Now, we may not get to this last part today. That'll probably be something you do on the next day. All right, so just so you have an actual definition of the remainder theorem. The remainder theorem states that if the polynomial is divided by x minus c, then the remainder is f of c. I'll show you what that means, but that's the formal definition. It says if you can quickly divide, this provides a nice alternative to evaluating f of c. So what it means is that we don't have to plug in the values and evaluate. We can just use synthetic division. All right, so we've already done synthetic division. That was that quick method of dividing polynomials. We used it when the divisor is of the form x minus c. Remember, we had like x minus 5. We used the opposite. And the last column was always the remainder. So you've already got all your techniques that you need. Okay, so what does the factor theorem say? It says f of x is a polynomial, therefore f of c equals 0. So remember when we had instances where we didn't get 0. If and only if x minus c is a factor of f of x. Well, it was because it divided perfectly, which made it a factor. Or in other words, there's just a different way of saying it. If f of c equals 0, then x minus c is a factor. If x minus c is a factor, then the reverse is true. Then f of c should equal 0. So basically, if we know a factor, we know that we will not have a remainder. It'll be 0. And then the reverse is if we get 0, we know we have a factor. Okay, so I'm just trying to give you some background information. All right, so here it is just restated as what we call a 0. All right, so if f of x is a polynomial and if c is a number such that f of c equals 0, then we say that c is a 0 of f of x. Okay, and then these are just your two other ways of saying it. Okay, so that's your formal background of this information. So what does this look like in a problem? It says use the remainder theorem to find the indicated function value. Okay, so what I'm going to do, okay, is I'm going to take out a piece of paper and I'm going to use synthetic division to solve this problem. Okay, so let me open up my document camera. Okay, I should have done this before, but that's okay. It's going, it's going, it's going. Slowly but surely. All right, here we go. So while that's loading up, I'm going to copy the example down. So the example is f of x equals x to the third minus 7x squared plus 5x minus 6. And what happens at f of 3? Okay, so there's my document camera. Okay, so there's the problem. Okay, so we want to know what happens at f of 3. So all we're going to do is we're going to take that technique of synthetic division. Okay, and I'm going to take the coefficients 1, -7, 5, -6. And then I'm just going to take 3. Okay, so I didn't have to take the opposite like I did in synthetic division when it's the remainder theorem and it's stated this way. We just jump right in. Okay, so I'm just going to bring down 1 like I did in synthetic division. 3 times 1 is 3. I'm going to add it. So I get -4. 3 times -4 is -12. I'm going to add it. So I get -7. Okay. And then 3 times negative 7 is negative 21. So I get negative 27. Okay? All right. So what I've done now is instead of plugging in 3 here and saying 3 cubed minus 7, 3 squared minus 5 or plus 5 times 3 minus 6, okay, and having to type that all into my calculator, this is my answer right here. So I know that f of 3 equals negative 27. And that's it. Okay. All right. So let's go back to my PowerPoint here. Okay. Let's try another one. Okay. So it says use the remainder theorem to find the indicated function value. All right. So let me copy this problem down and I'll switch over the document camera. So x to the fourth minus 5x to the third plus 5x squared plus 5x minus 6. We want to know what f of 2 is. Okay, so here's the problem. All right, I'm just going to make sure I don't have any missing. I do not have any missing variables in terms of 4, 3, 2, 1, 0. All right, so I'm going to take 1, negative 5, 5, 5, negative 6, and I'm going to evaluate what happens at 2. So instead of plugging in 2, I'm now going to use synthetic division. So I bring down the 1. 2 times 1 is 2. Add it, I get negative 3. 2 times negative 3 is negative 6. I add, I get negative 1. 2 times negative 1 is negative 2. I add, and I get 3. 2 times 3 is 6, and I get 0. So that means f of 2 equals 0. What that also means is that x minus 2 is a factor. Okay, meaning if I wanted to take this problem and convert it into a multiplication problem, which we're going to do, okay, one of the parts would be x minus 2. Okay, all right, let me pull up Delta Math really quick so you can. All right, so it says if f of x equals 3x to the 6 minus 1, then what is the remainder when f of x is divided by x plus 1? All right, so if I were to take this example, let me bring over my document camera in a split screen. Okay, let me scoot. There it is. Okay, now when you write this problem, this will be the last one, you got some missing terms in there. Okay, so we have 3x to the 6th minus 1. Okay, and they want to know what the remainder is when I go x plus 1. So it's the same idea. They've just styled the question a different way. So this problem really is 3x to the 6th plus 0x to the 5th plus 0x to the 4th plus 0x to the 3rd plus 0x squared plus 0x minus 1. So you cannot forget to make that adjustment when you do a problem that has missing terms. So that means I'd have 3, 0, 0, 0, 0, 0, negative 1. Now, because the problem was styled this way, where I had x plus 1 in my Delta Math question, I do have to use the opposite. So make sure you're paying attention to how they formulate the question. So if I run synthetic division, bring down the 3, negative 3. If I add that, I get 3, 3, negative 3, 3, 3, negative 3. I add it. Negative 1 times negative 3 is 3. And if I add that, it's 2. So that is my remainder. So let's see if I got it right because I did that kind of fast. So my remainder is 2. So I'm going to submit my answer. We're going to cross our fingers and hope I'm correct. Yes. Okay. And you can see here they've worked it out for you. Okay. or they've plugged it in. So remember, though, that the remainder theorem isn't necessarily always faster. It's just another technique. Okay. All right. If you've got any questions, let me know. And if not, good luck.